Okay. If you Google your Autodesk account, I want to go to Insight. Okay. So we can, you don't even have to sign in with your account, or probably you have, but it's for free. This is Insight. Well, this is Fusion. No, I want to go to Auto. Okay, let's go to Autodesk. Let's sign in. Okay, so in products, we can to type Insight. Okay, so this Insight, it's a plugin for Revit, and then you can download it for, I think it's for free. Okay, yeah. But as you can see, we have the 2016 plugin, 17, 18, 19, and we do have the 2020 plugin, but the 2021 plugin has not released yet. And I have tried this on 2021 and it's not working. I don't know, maybe it will be released in a few days. I don't know. Anyway, if you are working with 2020, you can use it. If you are working with 2021, you are not using it yet, but you can, you have to install this Insight plugin. You only have to download, click on the file that you download, and then it works immediately. So you don't have to do anything weird with this, okay? So if you are working with the 2020, try to download this Revit Insight. Revit 21. I think so. Yeah, I think the computer labs computers they have the 2021 version. I don't know, because when I taught this last year, by this time they had already released this 2020 plugin. So I assume that it will be released shortly. Anyway, I'm going to teach you how to use it. We are not going to post a classwork this week for 2021 because it's not working. But I assume that in a few days, you will be able to download this even for the 2021 plugin. If we are not able to do this, okay, it's not a big deal. We won't have a classwork or an assignment on that, but at least I'll show you how to use it because it's very useful. I mean, I use this in my professional career because it's very straightforward and you can understand what's going on just by doing something very simple and in a few minutes. Okay, so I think it's worth teaching that, and I hope the. But the good thing is that this is for free, so you don't have even to work with your. Yeah, I think you have to sign in with your Kinestate account, but it's free for everybody that has Revit installed. So even if you are a professional and you have a license, a Revit license, you can install this for free. Anyway, this is what we have to install, the Insight plugin. If you are working with the 2020 Revit, do it right away. If you are working with the 2021, we have to wait and see what happens. Okay, so this is the 2020. I'm working with the, or I'm teaching the 2020 version. And how can we make the most of this Insight? Well, there are a lot of features that we can do with Insight, but the best, I think, is the one that we can do with lighting. We are analyzing passive gains now. Okay, so if you tap here the Analyze tab, when this Insight is installed in your computer, you have these two icons, the lighting and the solar, they are on or they are highlighted. If you don't have the Revit plugin installed, you don't have these two icons here. Okay? So that works better in a 3D view. Okay, so in this 3D view, I'm going to copy let me duplicate view, and I will duplicate this one, and I will call this 3D solar passive. Okay, so make sure that you have a 3D view, and if you are working with this plugin with the solar analysis, make sure that this is well, you name this 3D view in a different with a different name. What can we do? Well, it's quite easy. You open the solar analysis, and you have this window here. There are different options. You have the custom, and you have the solar energy annual PV. We will use this option, especially in the second part of the course, because we are going to analyze the PV production on Revit. But today we're going to use the custom. And here, well, I don't know how it will show in your computer. Sometimes we have this, so you have to display all these settings. And here we have the result settings. Here we have the cumulative installation, or the peak, or the average. We have to use always cumulative. And the units, well, if you are working with imperial units, you can change to imperial units. The style is more, well, the style in the export, well, we will use this because you can export this to an Excel file, and it's quite useful. So we have the custom cumulative insulation. We set the units, BTU hour per square feet. And here we can either select all exterior surfaces, or we can select our user selection. Okay, so if we select user selection, you click here, and by default, you select the roof. Okay, so if you want to select the roof, just select it, and it's highlighted in blue. If you don't want to select it, you don't have to click Control or Shift or whatever. You just have this negative or minus sign, and you click here, and you are not selecting this. And here we are not selecting, be careful, because we are not selecting objects. We are selecting faces. Okay, so as you can see here, we are not selecting the slab. We are selecting just this. If you click here, you are selecting the lower surface of that slab. Okay, or if you are selecting this, you are selecting this face of the wall, or this face of the floor. Okay, there is something wrong, in my opinion, with this. You can't select windows. It would be useful, but you can't select windows. So how does it work? Well, before doing this, okay, before working with this option, by the way, sometimes you get frustrated. Okay, I can't close this. What's wrong? You have to click finish, because you are in this user selection. So you have to click finish, and that's it. And now you are working with Revit again. Okay. So before doing this, I want to show you how this works, because we have to understand what it does before doing it with the solar analysis. Let's show this sun path. Okay, so if we're working with this sun path on, here we have the south, the north, the east, the west. We know that the big openings are facing south, the small openings are facing north. And we're going to try, because in this these two guest speakers, or the two candidates that we have had, they are always mentioning that having big windows in Northeast, it can be it's a tough decision, because we need to find a balance between the size of the windows, the heat gains, the heat losses. So this is what we are going to do now. They are right. And now I'm going to try to show you how to quantify if we are making a good or a bad decision. From the energy point of view, there are other decisions that don't have to do with energy, but have to do with comfort. Sunlight is good. So sunlight heals. I mean, if you are living in a basement without any windows, your health gets worse. Okay, so just by having enough sunlight inside the room, it's good for health. So, and this is not about energy. So these are other. So opening good windows facing south, it's always a good decision, even though we can have energy issues. But from the aesthetics point of view and from the comfort point of view, having a good amount of natural light is always a good decision. Anyway, here we have this, and we can go to sun settings. You can do this with Revit 21 and 20 and 21, so it doesn't have anything to do with this solar analysis. So here we can select a still. So if we select a still day, you have a location. So let's assume that we are in Boston, I don't mind. And here you can select a specific day. So March the 11th, and the specific time, 14, okay, 2 p.m. So with this still, we can analyze this, we apply, and we have the sun path here. Okay, so here you can change if you don't want to change this with settings, you can change this, for example, March 17th. So you see how this changes, and you can change the time here. Okay, this is 3 p.m. or 10 a.m. and that changes. And if you cast shadows or you have the shadows on, then we can understand if we have heat gains or we don't through the windows. Okay, so in this case, it's clear that at this time we have sunlight here. And how much? Well, this area, so you see that the floor here, so part is with shade, part is with natural light. Okay, so we can understand this. If we move this to December the 21st, so that's the optimum case. So we need a lot of solar heat gains in winter. So when on the solstice, winter solstice, we need to maximize the heat gains or the solar gains. So that's the idea. And that works, these openings work pretty well because we don't have any abstraction and we have a lot of solar gains. So that would be good. What happens in June, when the summer solstice happens? Okay, that's interesting because look at this. We have a pretty thick wall, and at this time, as you can see, we don't have any solar heat gains in the floor because we have this thick floor. So that opening works as an overhang. It would work as an overhang if we had selected the right window. So look at this here, the window itself, the glass, is aligned to the exterior face of the wall. Then this is not an overhang because when the sun has entered, it's inside the building. So we have heat gains. So that's why, in my opinion, having the glass aligned with the wall, with the exterior face of the wall, I don't think is the best option. So we can always select this and we can press the tab, the space tab, and we push the window or the glass just inside the wall. Okay, so we can do this. Okay, just by doing this, just by working with a thick wall, you see that we don't need any element here. Okay, so this is something that you can justify with a teacher or someone is telling you, okay, you need shading devices. Well, yeah, sure, we need shading devices, but sometimes the thickness of the wall works as a shading device itself. And as if we are meeting the passive house standards, we need thick walls. Okay, so keep that in mind, because you might not need anything here, or you might, I don't know. Anyway, that works on June the 21st at 10 a.m. at noon. Yes, so you can see that we don't have any sun entering the building. Okay, so just by doing this, working with a thick wall and pushing or aligning the window with the interior face of the wall, it works as a solar protection on June the 21st. But usually June is not the hottest month. The hottest month is always July, at least in the northern hemisphere. So if we change this to July, do we have heat gains here, or do we have any? I'm going to hide this in view. Okay, you see that small, so this is the sun that it's entering the building. Okay, so in July, it doesn't work that well. And this is the 21st, so 30th. Yeah, so we are increasing the heat gains here. Okay, so this might not be enough. So I'm going to place it, but that's something that you have to keep in mind. Having thick walls help reduce the solar heat gains in summer, because we don't need an overhang. Basically, this thickness is enough to prevent the sun from entering in summer. Okay, so we have to keep that in mind. And on the other hand, if we are working in December, that's fine, because we have a lot of solar gains. Okay, so this is the first option. And this is the first visual analysis that we can have. Does it work? Is this what we want? We want this in December. Yes, we want this in December. We want to maximize the solar gains. And in June, we don't have any solar gains because this is in shade. Okay, so this option is not bad because we have this thickness, we have this thick wall, and we have this. It works like an overhang. This part of the window. Okay. But now this is one day. We can have other sun settings. So we can analyze this still or a single day. If we're analyzing a single day, so this is a specific moment. Okay, so we have that date and this time. If we analyze a single day, I think it's always useful because we can analyze this day from sunrise to sunset. Okay, so the sunrise is at 5:54 a.m. and the sunset will be at 17:51. So this is the analysis from sunrise to sunset. It's useful. And if you apply, well, we just see, because this is one day. So that day from the the sunrise is at 5:54, and the sunset will be at 17:51, 5:51 p.m. Okay, we're getting closer. So on, no, sun settings. On March the 21st, it's the equinox. So on March the 21st, we have 12 hours of sun and 12 hours of night. Yes, so this, well, kind of, maybe it's not the 21st, it's the 20th or the 22nd, but we're, the equinox is coming up. So by March the 20th, the 21st, we will have the same hours of day and night. Okay, so we can analyze a day, or we can analyze multi-day. And this is also useful because here we have a 1-year solar study. Okay, so we have a 1-year solar study from January the 1st until December the 21st. It's in 2010. I don't know why, but it doesn't matter because the year is not relevant. The relevant information is the day and the month. And here we can select the time. And that's interesting because we can analyze this, for example, during the office hours. If we know the schedule of the building, we are analyzing this from 10 to 4, or from 9 to 3, or from 8 to whatever. If we know the opening hours of that building, and this is what we have to compare, because if we compare only the solar gains, especially in winter, we compare solar gains with heat losses over 24 hours, this is not fair. Because so we don't have sun at midnight. And what if it's an office building and we have this schedule? I don't mind losing energy. Well, I don't mind losing energy because I have the energy system, or the heating system is not on after 4 p.m. because this is the schedule of the building. Okay, so if we want to create a good analysis in terms of heat losses through windows and heat gains through windows, we need to analyze the schedule, the building schedule. If we analyze this over 24 hours, it will never be positive because more than 12 hours, we don't have any sun. And if we don't have any sun, we don't have any solar heat gain. Okay, but here we can analyze this, or we can always analyze from sunrise to sunset. Okay, that will be, because from sunrise to sunset is when we have sun. We don't have sun during the night. We can analyze 1 year, or we can analyze winter, fall, summer, or spring. Or you can select the dates that you want from January the 6th until January the 15th, from sunrise to sunset, or from that time to that time. Okay, so it's very flexible. We can analyze the winter solar study from sunrise to sunset. Okay, so the winter, the winter is from December the 21st until March the 21st. Okay, so we're analyzing this winter solar study, 3 months. We apply and we click OK. And here you see that we have the sun path, the first day of winter and the last day of winter. Okay, so this is the sun path. You can use consistent colors, and now the sun path is easier to understand. Well, so first, before using this solar analysis, we need to work with the sun settings. What do we want to analyze? I want to analyze the winter performance of these openings or this building. But we have to set the sun settings before, because otherwise it will be confusing because we don't know what we are analyzing. So you can analyze a single day, or you can analyze a season, a winter, or you can analyze the whole year. And now I want to compare 2 analyses. I want to compare the winter analysis and the summer analysis. And then I will change the options, and I will compare again the winter and the summer analysis. Okay, so I'm going to do that quickly. And if you have the Revit 2020, try to do it. There is not a classwork, but try to do it on your own. If you have the 2021 version, let's wait a few days to see if they release the Insight plugin. Okay, so now just for the sake of just use the hidden line, and don't use and do not cast shadows, because for the solar analysis it will be confusing. Okay, so we have the sun path, that's useful. I'm going to work let's do this. I don't want to see the levels on this view. Okay, because I'm going to create another nice PowerPoint report, of course. no ideas. Solar, okay, custom, user selection, BTU hours. And what do I want to analyze now? How can I understand the solar heat gains that I'm having in this? So I think it would be great if I could select the window itself, the glass itself. I can't do that. There are other ways to do it, but well, I won't show it today. So what would I analyze? I would analyze an interior surface that is receiving the sun. And what is that surface? The floor. So I'm going to select, I don't want to select this roof because this is outside the building. I want to select the upper face of the floor. Okay. And so I will click finish. And I think we are done here. I have, well, yeah, let me check. I have selected this, finish. I have selected the right units, cumulative insulation, user selection, custom, the unit, okay. And I click update. There you go. Okay, so now we have this information. And you see how we have highlighted here. Well, we have different colors. So in this floor, we have the different colors. If we have this dark color, that means that at this point, we have the less solar radiation over this winter time. So we are not analyzing one day, we're not analyzing one moment, we are analyzing the whole season, 3 months. Okay, so that's why this analysis is relevant. And the most relevant information is the BTU. We have a lot of information here. We've been analyzing 2,047 square feet. So this is the area of the floor. And this is, I'm going to write, well, I'm going to copy this actually. Because I need to remember the first solar analysis. And I can make, okay, I can take another screenshot of this. And I'll place it here. Okay, so here we have the scale from 0. This is the maximum, this is the peak heat gains that I can have, BTU per feet square. And I have to remember this number because this is the amount of energy that I'm gaining through these windows. It's a lot of energy. Now I'm going to compare this with the summer. So I have to change the settings. So I have to go to sun settings. And now I'm going to use the summer solar study. It's from June the 21st until September the 21st. I can apply. So I change this. And now I analyze this again. The custom selection, it's still the same. I want to check that it's the floor. Finish. I have cumulative, BTU, update. Okay. And as I expected, I have this green area here. This is the area that is receiving sun, and the rest of the dark area is not receiving any sun. As you remember, I was using this just for the steel analysis on June the 21st. We didn't have any solar gains here, but as the sun is moving, especially in September, we will be having solar gains in June, July, September, and the sun is moving in this path. So we are having some solar gains. But now I can compare this. So I take the screenshot of this solar analysis. Here. And I close and take a different screenshot. Here you go. Okay. Bring to front. Look at this. We have the winter, and this is the summer. Well, look at this number. This is 11 million BTUs, and this is 4 million BTUs. Okay, if it were the other way around, it would be a very bad design because we would have, we need to have more solar gains in winter than in summer. Okay, so that works well. But this is too much energy. Can we reduce this? Okay, so let's try to reduce this. What would we do if we were architects? Well, the easiest way is to create an overhang in that roof. Okay, so I will edit the footprint and I'm going to create an overhang. Okay, so this is what my mother would do. I mean, my mother is not an architect. So this is common sense. So if you want to protect a window from the summer sun, just create an overhang, and let's find out if it works. Because I want to run another solar analysis. I want to make sure that I have selected the same floor. Yes, I have. Finish. The same cumulative insulation, BTUs, the same area. So I'm analyzing the same area. So I update. Okay. So is it good? It is. Because if we copy this now, okay, with this second option, this insulation is 500,000 and it was 4 million without the overhang. Okay, so we're getting better. So if I want to take another screenshot, so this is the option with the overhang in summer. Okay, so just with this design decision, we have improved a lot from 4 million to 500,000. It's a lot of improvement. And this is just a simple decision, just like extending this roof here. Does it affect the winter? Well, we have to find out because here we didn't have any overhang. Does this overhang affect the winter heat gains? So let's do it again. So we have the overhang. I have to change the sun settings again to winter, December to March. Okay, apply. And I have to go to solar, selection, make sure that the floor is selected, finish, custom BTU, update. Okay. Yeah, so this overhang affects the solar heat gains. Okay, so now we are comparing the winter performance, 11 million. This is close to 4 million. The summer performance, 4 million. We have the overhang, 500 with the overhang. So is it a good option? What do you think?
Yes.
You think it's a good option? Why? But yes, no, why? Can you please elaborate?
Um, I think it's a good idea because with the overhang, because in the summer it brings in less BTUs coming into the building, so it's less of a heating load during the summer.
Yeah, sure. For summer, it's a good option, but we are gaining a lot of. So this is a heating load that we are gaining for free. Okay, so this 11 million, and we are losing a lot. Well, things are not good or bad, so that's why we tend to think that having an overhang is good for summer. Yes, it's good for summer. Does it affect winter? We should work with an overhang that because I have created that overhang. I don't know. I didn't measure. But I'm sure that there's an optimum overhang in which we can reduce the heating loads or the cooling loads, but again, we can maximize the solar heat gains in winter. And this is what we have to try to create now. Since we have this thick wall, I think the overhang that I created doesn't have to be that long. It can be shorter. And a shorter overhang probably will work well in summer. So let's do the winter analysis again. Okay, so you see that there's an overhang here, but it's not that big. It's just this, because I have to add this distance here. I add up this and this. Okay, because the window now it's there. If the window were if aligned with the outdoor layer, then I would have to increase the overhang. But now we have this window here, and we have the thickness of the wall. So I think that will be enough. Well, let's find out. Um, so I'm going to, this is the winter. I'm going to analyze again. Custom, the floor is selected, the same units, finish, and update. Okay, that's quite good because I have here 11 million, which is almost the same that I had before. Okay, so this overhang doesn't affect uh, the winter performance. So it's 11 million, and the best option, yeah, it's 11,700, and this is 11,400. Okay, it's not bad. And I want to create a screenshot here. Now I'm going to analyze the summer settings. So I change sun settings to summer, June to September, sunrise to sunset. Apply. Okay. solar. Select the floor, finish, units, update. And 23,000. I think there's something wrong with the sun settings. Yeah, because it's just one day. Okay, so this has not changed. So it's from June to September, apply. Yeah, so this didn't show up, so I have to do it again. BTU update. Okay, this is 3 million BTU. And what was the best option? Okay, so here I have 500. And without the overhang in summer, I had 4 million. And this is 3 million. Yeah, something has changed, but well, I'm not happy with this one. So I'm going to make this overhang edit footprint, and I'm going to make it a little longer. So if I make it, yeah, now it's a little longer. And I analyze solar selection, the floor, units, finish, update. Okay, it's 1 million. I think this option would be the best. So in summer, we have 1 million. And in winter, we change the sun settings to winter solar study, sunrise to sunset, apply. We select the floor and update. And we have 10 million. Okay, with these two options, I have 1,900,000 in summer. I have 10 million in winter. With the original option, I had 11 million in winter, so I have not reduced a lot from 11 million to 10 million. That's fine. And that originally I had 4 million, and now I have 1,900,000. Yeah, so I have reduced the cooling load by half. So I think that would be the best option. But I have different alternatives. Okay, so I have this and this, So that's the best in summer, but it's not the best at all in winter. This is the best in winter, but this is the worst in summer. And here I have something. This one was neither good for. Okay, so in this one, it's not as bad in winter, and it's almost the best in summer. And now we have to compare this to what? We have to compare this to the heating in winter and the heating load in summer. And what is this? The heating load in winter is always the U value times the area times indoor minus outdoor temperature. Okay, but what are the units of this? This is BTU hour. This is the heating load. We have to turn this into energy. What do I have to do to turn power into energy? Hello?
Can you repeat the question?
Yes. What do I have to do to turn, this is power, and I want to turn this into energy. So what do I have to do?
I don't remember off the top of my head, but wouldn't the units for this, would it be like BTU hour feet squared?
No, this is BTU. So let's work with these units. The U value is BTU hour feet square Fahrenheit. The area is in feet square. The temperature is in Fahrenheit. Okay, BTU hour feet square Fahrenheit, like this. So we cancel feet square and Fahrenheit, and we have BTU hour, and this is power. Then energy, because those units are energy, this is BTU. So I have to multiply by
BTU?
if I want just BTU.
Do you multiply it by hour?
By hour. How many hours? Well, we are creating, or we are analyzing this in winter. How many days? 30 days times 3 months times how many hours? And this is a tricky question here, because we are analyzing this from sunrise to sunset. So we need to find out how many hours from sunrise to sunset we have from December the 21st until March the 21st. And this is the figure that we have to compare, because this is the energy that I'm losing, and this is the energy that I'm gaining. So this is the balance that I need to compare. Okay, since finding out the hours that we have in winter from sunrise to sunset is not easy, because we have to do some math. I'm stopping the lesson here, and we will continue on Monday. Okay. So do we have a classwork this week? I will post something. It's something about therm. because I assume that you don't have anything or you don't have Revit if you are working with the 2021 version. We don't have this solar analysis. So I will post something quite easy with Therm. Okay, but yeah, by Monday you have to submit another Therm exercise, something easier than you were supposed to do before with this wall to roof connections. That it's more complicated. And well, try to work with this. And I would appreciate if you tell me how many of you are working with the 2021 version and how many of you are working with the 2020. So if you can use the chat now to tell me 2021 or 2020, I would appreciate that. So